Hello everyone, welcome back. Today I am going to start with a new chapter which is factorization. So before I begin with factorization, this chapter is equally important in class 8 as well as in 9. So those who have in 9, they know the concept of factorization, but still I started with the definition or what do you mean by the word factorization. In this part, I am going to discuss the factorization and what are the methods we are going to apply to find out the factors. Now, the factorization means if an algebraic expression is split into two or more than two irreducible expressions. Two or more than two irreducible expression. Then we called it as factors. For example, if I write 2 minus 3x and 2 plus 3x 2 minus 3x into 2 plus 3x, so this will be equal to 4 minus 9x square. This is equal to 4 minus 9x square. So now see, this is a given expression. It is expressed as a product of 2 or more than 2. Here it is 2 irreducible expression. You cannot further simplify 2 minus 3x. So it is an irreducible expression. So these two are called as a factors. These two are called as a factor of 4 minus 9x square. Now, what are the methods? First, we are going to discuss by taking common. By taking common from the given algebraic expression. The first method to find out the factor is by taking common. By rearrangement of the terms. Second method is rearrangement of terms. Third one is application of formulae a square minus b square is equal to a plus b into a minus b. Now in this part particularly we are going to use this formula, or a cube plus b cube. Formula is a plus b into a square minus ab plus b square. A cube minus b cube, which is equal to a minus b into a square plus ab plus b square. So we are going to use these three formulas under the application of this formula. Then we are going to learn about the middle term factors. Middle term factors, and the last one we are going to discuss the factorization of cubic expression. Factorization of cubic expression. So under this it is almost cover all the classes, class 8, class 9, and factorization of cubic expression you will find it application in class 10. So, I'm going to discuss and solve some examples to you to explain each and every process. So, now I'm going to start with the first process. First process is factorizing by taking out common factors. Now, for example, an algebraic expression is given to you. An algebraic expression is given to you. Suppose if I am taking 15ax cube minus 9ax square. 9ax square. Now this is a polynomial. This method, it is not restricted to this type of factorization, but we are going to apply each and every time. The first rule is, whenever you are doing a factorization, you need to first check if any term is common or not. Now see, what is the rule of taking common? You need to find out the SCF of these two terms. So now 15ax cube can be written as 3 into 5 into a into x cube, or you can split it into many terms like x into x into x, and 9ax square. So this 9 can be written as 3 into 3 into a into x square. Clear? So now find out the SCF of these two terms. Find out the SCF of these two terms. So SCF means highest common factor. That means the factors which are common to both the terms. 3, here a, x cube, x square. So highest is x square. So from these two, we need to take common 3ax square. 3ax square. Now we need to give the brackets. Now divide each term by its SCF. So 15 divided by 3 is equal to 5. A cancel. X cube by x square, it is equal to x, minus 9 divided by 3 is equal to 3. A cancel, x square cancel. So the factors of this is 3ax square into 5x minus 3. Clear? Suppose if we take another example, 21 py square minus 56 py. Now, this is a process I explained to you. Practically, each time we are not going to follow this entire process. 21, first we need to take out the common from the numerals. 21 and 56. Find out the highest common factor from 21 and 56. 7 into 3. 21, it is divisible by 7. 56 is also divisible by 7. So 7 you can take from 21 and 56. You can take 7 common. This is the maximum term. We will take 7 common. Now look at the literals. P. Power of P is 1. Here also 1. So we will take the P common. Here y square and here y. What is the lowest term? Lowest degree of y is 1. So we will take y common. Now divide first coefficient by coefficient and then corresponding literals. 21 by 7. 3. P divided by P. 1. Y square divided by Y is Y. Minus 56 divided by 7 is 8. Py divided by Py. So this is the way we are going to perform factorizing by taking out common factors. Now we are going to discuss these two problems. First, let us discuss this problem. First, we need to take out common from the numerals, that is 3 and 6. 3 and 6. 3 multiple of 3, 6 multiple of 3. So you can take 3 common, that is the highest factors. A, B, different terms. So there is no way to take common. Now see, x square plus y square is present in this term. X square plus y square is present in this term. So we will take x square plus y square common. Now once you take the common, then divide each term by the term we have taken common. So 3 by 3, 1. X square plus y square, x square plus y square cancel. The only term left here is A, plus 6 divided by 3 is equal to 2. X square plus y square, x square plus y square cancel. So we get 2b. So the factors of this algebraic expression is 3 into x square plus y square multiplied by a plus 2b. Now let us solve this one. First, we need to take common from the numerals. 10, 5 into 2, 15, 5 into 3, 35, 5 into 7. Now see, 5 is common. That means all the numbers are divisible by 5 and that is the highest factors. So we will take 5 common. Look at this term A, B. So we will not take common. Now look at the third term 2p plus q to the power 3 to the power 3 and this is 1. And this is 1. This should be 2. This should be 2. So what is the least power of 2p plus q is 1. So we will take 2p plus q as common. 2p plus q as common. Now once you take the common, divide each term by 5 into 2p plus q. 10 divided by 5 is equal to 2a 2p plus q to the power 3 divided by power 1. So the factor left is 2p plus q square minus 5 is common. So 3b 2p plus q square and yet 2p plus q. So the factor left is 2p plus q. 5 is common, so the factor left is plus 7. Student, today I'll show you some sum based on factorizing by taking out the common factor. In the next part, I'm going to solve some more problem based on this method. Clear? Till then, it's goodbye.